but her, so she have close substitute? No. For her, it is luxury or necessity? It is necessity. For she has more time? Yes. Sorry, it narrowly defined the market? Yes. And time for her, the time period is long? Yes. So if you compare all these options, you can find out that she's not ready to change her car. So for her, the elasticity for gasoline is inelastic because gasoline majorly depends on her car. Car is old and she's not ready to change. So that creates the big decision making part, that is its demand is inelastic. Okay, if you understand the concept here, also answer this question. If the quantity demanded of a certain good responds only slightly to a change in the price of the good, then what is the answer, Isaac? Marilyn?
I'm thinking.
Okay.
Is it B?
Spike?
I think it's B.
Well done. Because slightly changes, right? There's a respond, there's a change in price, and the quantity demanded change slightly, means there is a less change in quantity demanded. So a good will have a more elastic demand. We just talk about that. Answer this, please. David, Subhan, Pinyo, Nam.
Is it C?
I think it's C too.
I think it's B.
So I heard C and B. So what we are talking about, we're talking about inelastic demand, right? But this one answer is B. Why not C? Because in longer term, everything would be elastic because we would be having more substitute in longer period of time. Somebody already talked about that. Okay, let's have a break. And then we talk about how we calculate elasticity and what is the formula for that. So we are going to have 15 minutes break, and after that we'll start again. Okay. Okay guys, welcome back after a short break. Okay, now let's move forward. So the previous discussion was about the elasticity. What do we mean by elastic and inelastic demand? And now let's compute the price elasticity of demand. The price elasticity of demand formula is percentage change in quantity demanded divided by percentage change in price, which means percentage change in quantity demanded divided by percentage change in price. That is elasticity of demand, price elasticity of demand. Okay. So price elasticity of demand, we denote it with small e. So how we calculate percentage change in quantity or percentage change in price? So the percentage change we calculate normally, the mathematical formula is new value minus old value divided by old value. New minus old divided by old. That is how we calculate percentage change. Okay. But this percentage change has inherent flaw. And let's explore this. So assume we are on a point A, which is on which price is 4 and quantity is 120, and point B is price is 6 and quantity is 180. So the method that we use to rectify those inherent flaws, we call that midpoint method. But let's understand the potential flaw from this formula. When we calculate percentage change, we discuss that how we calculate percentage change, new minus old divided by old. So this formula has inherent flaw. So ideally, if we are here and we want to calculate elasticity from A to B, so answer should be equal, either you are on point A or either you are on point B. The elasticity should be the same, either point A to B or point B to A. But in this case, it's not the case. If we use this formula to calculate the percentage change, so the flaw is that if we want to calculate the change from A to B, the price change, so the price change is 50%. How this 50% came from? From A to B price changes, the new price would be 6, old price would be 4, old, so 2 by 4, we have 0.5 or 50%. The quantity is, new is 80, old is 120, so that is old, that is new. So we have 40 over 120, which is minus 33%, or just you can say 33%. Ideally, this is minus, but since we are talking about price elasticity of demand, it means in demand, price and quantity, they are inversely related, not proportionally related. So the name implies that we have automatic minus sign here. If we don't write it down, it's okay. But theoretically, yes, there should be a minus. But since we're talking about demand, so this is obvious that we have either minus here or either minus here. So one should be minus, okay? So if you see some kind of like minus here, so don't worry about that. If you see B to A, so from B to A, it's too much mess here, let me just delete. So if we go from B to A, from B to A would be our new point and B would be our old point. So if we want to find out the change in price, so 4 minus 6 divided by 6, answer would be 2 by 3, it is 33%, or minus 33%. I just explained you the reason. And if we go from point B to A, new is 120, old is 80. You see 40 by 80, answer would be 50%, right? So if we calculate on the basis of these formulas, the percentage change in the price elasticity of demand from A to B, formula is percentage change in price divided by, sorry, percentage change in quantity divided by percentage change in price. Our elasticity is 0.66. If from B to A, elasticity is 1.5. So you see the erroneous result here. One can say that demand is elastic. Why? Because 50% change in price, sorry, 33.3% change in price causes 50% change in quantity. So you can say that as compared to 33%, 50% is more. So 1.5 suggests that the demand is elastic. But on the other hand, it says that 50% change in price causes 33.3% change in quantity demanded. You can say that this is inelastic. So which one, which result we believe in? So the fault that lie is through this formula. If we calculate percentage change, so this formula give us erroneous result. So that's why we use midpoint formula. midpoint formula says that in order to calculate the percentage change, why not we just take a midpoint to calculate percentage change? So rather divided by new value minus old value divided by old, divided through midpoint. So now the formula of percentage change in calculating the elasticity would be new minus old divided by midpoint of both point, right? So remember, from now on, the formula is the same. For elasticity, formula is percentage change in quantity demanded divided by percentage change in price. The formula is same, but how we calculate the percentage change? We calculate through midpoint. So use this midpoint method of calculating percentage change, because it gives you a better way to calculate percentage change in elasticity. If we use that, our answer would be the same. So whether we go from A to B or whether from B to A, answer would be, elasticity would be the same, right? Okay, let's calculate the midpoint formula, elasticity through midpoint formula of this example. So we have example, if the price of an ice cream increases from 2 to 2.2, the amount you buy falls from 10 to 8 cones. So let's calculate. So we know that elasticity is equal to percentage change in quantity demanded divided by percentage change in price. So now percentage change in quantity is equal to new quantity, which is 8 cones, minus old quantity divided by midpoint. What is the answer here? Minus 2 divided by 9, which is 2 by 9. Answer would be 22%, right? %. And percentage change in price, so 2.2 minus 2 divided by 2.2 plus 2 divided by 2. Answer would be 9.5. So if we interpret this elasticity, so numerator is called percentage change in quantity demanded, denominator is called percentage change in price. So you can also find out that the result would be above 1. 2.32 shows us elastic demand. How? You see,